This is the homework for 267, 268, and 269. For number 267, Sylvia simplified the expressions on the expression mat. Some of her work is shown, or all of her moves legal. So if you look here, X, 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 and X, this is a legal move because they are equal value. They're the same tile. So identical tiles you can remove from the expression comparison map. This one over here, this move, what is the opposite of a positive one? Negative one. So when she flips that tile into the positive region, it becomes a negative, and negative and a positive create a zero pair. But when you look at this move here, the opposite of a positive is a negative. And so here, you cannot remove this because these two do not create a zero pair. So that is not a legal move. Problem 268. Pause the video and read the meanings and methods math notes for associative and identity properties. Problem 268. Here's the given expression. Next, the grouping has changed, the parentheses. So the terms x and 10 were grouped. Now 3x plus 8 plus x is grouped. In order to do that, you use associative property of addition. When you're grouping terms that are applying addition, doesn't matter how you group them. Order of operations doesn't matter. Now we have 8 plus x and x plus 8. This is the commutative property addition. So the order of these two terms has been changed. So commutative property addition is 2 plus 3 is the same as 3 plus 2. So it doesn't matter which order you go in when you're dealing with addition. Now I've combined like terms. 3x plus x is 4x. 8, 8, and 10, and 10. So I combined the x terms. Here I have 8 plus 10, and now I group them. And again, grouping is associative property of addition. Now we have 8 plus 10 is 18. Well, just like up here, combine like terms. Problem 269. Figures 1, 2, and 3 were given, and you needed to draw 4 and 5. Well, figure 1, you can see, is a 2 by 2. Figure 2 is a 3 by 3. Figure 3 is a 4 by 4. So you should notice that the figure number relates to the actual figure because figure 2 is a 3 by 3, so that's 1 more than the figure. Figure 3 is a 4 by 4, that's 1 more than the figure, so it's 4 by 4. So figure 4 is going to be a 5 by 5. Figure 5 is going to be a 6 by 6. For part B, you need to find what figure 10 would look like. Well, if you continue that pattern, or if you use this pattern, that the figure is just one more than the figure number, so the length and width is 1 more than the figure number. Figure 10 would be an 11 by 11 square. And that figure would have 121 tiles because 11 multiplied by 11 is 121. So this figure would have 6 by 6, that would have 36 tiles, 25 tiles, 16 tiles, 9 tiles, and 4 tiles, 2 by 2. What would figure 100 look like? It would be a 101 by 101 square. Problem 269C, Cami has a different tile pattern. She decided to represent the number of tiles of her pattern in a table. So we're going to use what Cami had. She had 1, 2, 3, 4, and 5, 9, 13, and 17. So you can also use this to find the pattern. So as the figure number increases, so the figure number is increasing by 1, you can see that the number of tiles is increasing by 4. So it's at a constant rate. So for figure 5, increased by 1, 4 plus 1 is 5. So 17 plus 4 is 21. Now how many tiles would figure 8 have? Well, you can just continue. 5 plus 1 is 6, plus 1 is 7, plus 1 is 8. 21 plus 4 is 25, plus 4 is 29, plus 4 is 33. So each figure has 4 more than the previous figure.